As you can see here on the leg assembly, we've managed to integrate the servo motors without compromising the structural integrity.
Good. So the chest plates fold outwards, allowing the matrix chamber to rotate before the legs compress.
But how does the hitch lock in?
We need to ensure the mechanical joints align perfectly with the forearm plating.
What if we adjust the servo placement slightly to accommodate the wiring harness? We need to reinforce the structural integrity here on the chest plate.
If we reroute the energy conduits through the shoulder joints, pay close attention to this specific component's integration.
The interface detail on the manifold needs adjustment before production.
Agreed. The revision stabilizes the entire assembly.
Align module Gamma 7. Confirm position and secure the braces.
The vision for Optimus Prime is not just about building a machine, it's about redefining the future of automation.
The rotational actuator is showing excessive thermal loading at peak torque.
We could upgrade the cooling loop, but the real issue is the metallurgy in the main housing.
As you can see, the detail on the matrix chamber is exquisite. We source the finest materials to ensure screen accuracy and durability.
We need to adjust the servo alignment on the knee joint by at least 3 degrees.
The current tolerances are too tight for the...
The schematic shows a clearance issue on the left actuator.
I see it. Adjusting the crane trajectory now.
Look at the fluctuation on this servo joint here.
It's within tolerance, but the thermal output is slightly elevated, according to the schematic.
Alignment confirmed. Torque levels are nominal.
Locking mechanism engaged.
All right, moving to the next sequence.
Joint articulation is within tolerance.
Confirmed. All systems green.
The hydraulic line on the left arm is secure.
Pressure test initiated. Readings are stable.
Precision check on the manipulator. We're showing a slight deviation on the Z-axis.
Adjusting dampeners. Calibration successful.
We're seeing a slight variance in the servo alignment here on the 12th axis.
Confirmed. The schematics show the tolerance level is marginal at full extension.
The schematic for the localized force field generator in the chest is finalized.
Good. Let's review the articulation points on the primary servo here.
If we use the reinforced actuator here, the torque improves.
But the weight displacement on the lower joint becomes critical. We need to adjust the housing tolerance. The matrix chamber integration is seamless. We've optimized the layering for maximum durability.
What about the thermal venting on the lower quadrant?
We've addressed that in the schematic review.
This joint allows the full 180 rotation we needed.
But the torque on the lower connection is still showing stress fractures.
Agreed. We reinforce the plating before the next test.
The primary concern is balancing the heavy torso. We've distributed the inertial weight across the structural frame of the legs to maintain stability.
Rerunning the stress test on the optical sensors. Thermal load is minimal.
Approved. The tolerances are within the required parameters.
We're seeing some stress fractures on the lower joint assembly.
The calibration is off by 0.4 millimeters. I'll adjust the parameters now. The hydraulic servos here allow for the full 90-degree rotation.
But what about the integration with the vocal processor? The clearance is minimal.
We've accounted for that in the phase array. The clearance on the hydraulics is still too tight. Watch this joint here.
Okay, pull the main strut back another 2 millimeters. That should do it.
If we move the shoulder assembly here, the clearance issues resolve.
That aligns with the structural integrity scan. Proceed with the iteration.
Let's look at the leg assemble. Zoom to the knee joint.
The tolerances here are still too tight.
I agree. We need more clearance on the main cylinder.
Alignment looks good on the secondary axis.
Confirmed. Proceed with locking sequence.
Torque to spec. How are the diagnostics looking?
Reading stable. Joint movement confirmed. We are good to go.
Check the alignment on the left torso strut.
Reading green on all servos. Proceeding with the weld sequence.
The torque sequence is complete. We have a secure lock.
Acknowledged. Initiating movement cycle and running diagnostics.
Alignment is complete. We are within tolerance.
Confirmed. The synchronization sequence is holding steady.
All servos responding within tolerance.
Confirmed. The main articulation passed stress test 7.
Final report shows ready for deployment.
Status report on the torso assembly.
All readings nominal. Armor integrity confirmed on the right shoulder joint.
System check complete. We have full functionality. Excellent work. The base response is incredible.
The servos are responding within tolerance. Look at the data on screen 3.
Adjusting the flow rate now.
Head matrix alignment check complete. Status, optimal.
Initiating dynamic stability test.
Impact readings, nominal.
Structural integrity holding at full load.
Wow, look at the detail on that.
It's incredible. I can't believe it's actually here.
Check out the matrix chamber. Look at the detail on that. It's incredible.
I can't believe how big it is in person.
The paint job is flawless.
Wow, did you see that?
This is unbelievable.
It looks absolutely real.
Final systems check complete. All parameters are nominal.
Confirmed. The transformation sequence is fully optimized.
Outstanding work, team.
Look at the detail on that.
It's incredible how smooth the movements are. Wow, look at the detail on that. It's incredible. I can't believe it's real. He's huge.
Look at that, he's actually doing it.
Oh my God, the blaster!
This is incredible.